Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome to all of you in the physics online lecture series. The topics that are going to be covered in this video lecture are waves as a carrier of energy, relation between velocity, frequency, and wavelength, construction and working of ripple tank. Waves as carriers of energy. As we know that waves can transfer energy, but waves cannot transfer matter. So we can say that energy can be transferred from one place to another through waves. For example, here in the picture, we have an example of a string in which the circles are shown as the particles of the string. Let's take an example. When we shake the stretch string up and down, we provide our muscular energy to the string. As a result, a set of waves can be seen traveling along the string. The vibrating force from the hand disturbs the particles of the string and sets them in motion. These particles then transfer their energy to the adjacent particles in the string. Energy is thus transferred from one place of the medium to the other in the form of wave. The energy in a wave depends on the amplitude of the wave. If we shake the string faster, we give more energy per second to produce wave of higher frequency, and wave delivers more energy per second to the particles of the string as it moves forward. Similarly, water waves also transfer energy from one end of pond to the other end. Relation between velocity, frequency, and wavelength. We also have a relation which gives us the information that frequency and wavelength of a wave are inversely proportional to each other. Here in this diagram, we know that the distance between two consecutive crusts is known as wavelength. And amplitude is also seen, which is actually the maximum distance of the crust or the trough from the mean position. We also come across from this picture that velocity of the wave is in the direction of the propagation of the wave. Let's move towards the explanation of the relation V is equal to F lambda. From our previous knowledge, we know that a wave is a disturbance in a medium which travels from one place to another place. Similarly, wave velocity can be defined as a specific velocity of traveling which a wave possesses. We also know the distance formula, which is distance is equal to velocity into time. From this relation, we can derive the wave velocity. So V is equal to d by t. From our previous knowledge, we know that the time required by a wave to complete one cycle is called time period. So here, if t is the time period of wave, then distance covered will be equal to its wavelength, which is actually already defined as the distance between two consecutive crusts. So V is equal to lambda by t. We also know that frequency and time are reciprocal to each other, so we know that t is equal to 1 by f, or f is equal to 1 by t. So finally we come to the relation which is V is equal to lambda f. These relations tell us that frequency and wavelength of a wave are inversely proportional to each other. Ripple tank. Ripple tank is a device to produce water waves and to study their characteristics, which are reflection, refraction, and diffraction of water wave. This apparatus actually consists of a rectangular tray having glass bottom and is placed nearly half meter above the surface of a table, which is actually shown in the figure. Waves can be produced on the surface of the water present in the tray by means of a vibrator, which is actually an oscillating electric motor fixed on a wooden plate. This wooden plate is actually over the tray in such a way that its lower surface just touches the surface of water. On setting the vibrator on, this wooden plate starts vibrating to generate water waves consisting of straight wave fronts. An electric bulb is hung above the tray to observe the image of water waves on the paper or the screen, which is present below the table. The crest and trough of the waves appear as bright and dark lines, respectively, on the screen. There is a precaution while using ripple tank that there must be only one lamp and it should be exactly over the table. Otherwise, the wavefronts will not be straight and the crest and trough appears differently. And there should be only one lamp in the room. Characteristics of water waves. Number 1. Reflection of water wave. When waves move in one medium, fall on the surface of another medium, they bounce back into the first medium such that the angle of incidence is equal to the angle of reflection. This can be easily explained by putting a barrier in the way of water waves which are being produced in the ripple tank. Let us suppose that this black line is a barrier which is placed in the ripple tank. Then the incident waves in figure A touches the barrier and are reflected back as shown in the figure B. Here we come to know that the angle of incidence and the angle of reflection both are same. So this is a way that how we can find the reflection of water waves by putting a barrier in the way of water waves in the ripple tank. Refraction of water waves. When a wave from one medium enters into the second medium at some angle, its direction of travel changes. This can be easily explained by a ripple tank by simply placing a block on the surface of the glass, which is actually submerged into the ripple tank. This block will cause the water to be shallower at its surface, whereas where the block is not present, the water will be deep. We also know that the speed of water wave depends on the depth of the water. We also know that the frequency will remain the same as the frequency of the vibrator. So when the water waves move from deep water to the shallower water, then their wavelength changes, which actually decreases. So for the observation of refraction, we put the boundary of the deep water and the shallower water at some angle. So as the water water waves come from the deep side to the shallower side, their direction changes. And why it changes? Because we know that the direction of propagation of wave is always perpendicular or normal to the wave fronts. This is how the change of path of water waves while passing from deep water to the shallower water explains the refraction of water waves. Let's move towards the diffraction of water waves. As we know that the bending or spreading of waves around the sharp edges or corners of the obstacles or slits is called diffraction. So for this purpose we have to put two obstacles in line in such a way that separation between them is equal to the wavelength of water waves. When water wave pass through these small slits, then the waves will spread in every direction and change into almost semicircular pattern as shown in the figure 1. Diffraction can only be observed if the size of the obstacle or the slit that is produced because of that obstacle is comparable with the wavelength of water wave. In the second picture, the slit is larger, so small diffraction is produced. So finally, there are some multiple choice questions whose answers are also given. You have to solve these MCQs on your notebooks. At the end of this lecture, you will be able to solve this assignment. This assignment will also help you to check the understanding level of the whole chapter. Thank you so much.